Okay, so then the question becomes like, how can we actually make that $128,000? Like, how's that figure actually come into play? And that's done through like the Massachusetts ConnectedSolutions. There's different income strategies that they implement to incentivize people to, install these systems. And I'm not gonna go over this slide. You guys will go have access to all this, and we can go into more detail later. But for me, I think it's easier to actually take a look at like real world examples. So this is actually the system that we installed there. It's the Franklin A-Gate. It's a good system. But instead of like looking at this as just the house, this could also be the building. So, you got the solar panels, you got the A-Gate inverter, you got a battery system, and then you have the grid, and you have an EV charger, and then additional component is the generator that I don't have showing here right now because we don't have ours currently connected. The clinic obviously would have the generator module. So the first way that we make money, typically most systems don't have the batteries. It's like net metering. It's like one of the first things that came out was, you have the solar panels and then you pass that, use it for the house, and whatever you don't use gets passed off to the grid. And they'll give you a credit for any kilowatt you push out to the grid. You could take a kilowatt later at any time, and here in Massachusetts, no problem. So that worked great. It put a lot of power into the grid, especially during the day, the sunny days, but it still left a void or a problem where what happens at night, or what happens when people are getting home from work and starting to turn on their air conditioning. So that moments of peak demand that are starting to spike just as the sun is starting to set, and that production is starting to go down. So that's where now they started incorporating battery systems into the system design. So what does a battery system allow? So instead of just exporting everything out to the grid, go ahead and charge up the batteries. And then once the batteries are charged at 100%, the inverter knows fully charged. Okay, now you can start exporting it. So you're still doing the same net metering back and forth after that. The battery's fully charged, but what do you have now? You have like a gas tank now on the side of your house that's there ready for, any event. The power goes off, you get disconnected, whatever it may be, it just automatically kicks on to power up the house. So that works great, but it offers like an additional incentive. And this is like where the batteries are now becoming so popular because of the fact that in those moments where people are getting home from work and AC usage is going up and solar production is going down, EverSource is strapped, so they need more power. What are they currently doing? They got to get more generation. They got to fire up the power plants. They're currently getting power from Canada, so it takes a lot of money to get this power from Canada all the way down here to supply during peak demand. Or they can start installing these battery systems that could take power when they have it, store it in the system, and then export it when you need it. So for this example here, this is actually a live shot of us actually participating in a EverSource event. So they requested from us to discharge, and they communicate with our A-Gate. So their systems are able to integrate directly with our A-Gate, and the A-Gate's able to tell them, hey, our battery is currently at 97%. We're able to participate for 3 hours. And the EverSource tells, hey, you guys want to participate? We say yes. And this happens all systemically, automatically, and they'll start pulling. And this is what's happening here. So you're currently discharging. This is the discharge rate, 15. It's 3 battery packs at 5 each. So 15 is the total capacity of the house. And it starts exporting out. At the same time, we're still producing 8.8 kilowatts, which is still less than the 10, 11 that we get during peak because the sun's starting to set. And then the consumption is down to 0.7. So you take the 15 plus the 8 that's being produced minus the 7 that we're consuming, and we're pushing out 23.1 at a moment that EverSource is strapped and like at peak demand. So like this becomes now a huge value to EverSource. And this is why they incentivize us to install this. Like our installer took forever to put this in, and it was EverSource like pleading us, hey, can you call your installer and have them turn it on? So that goes to show how much they want this stuff. So like if you have any issues going on with the bill, it may be a perfect opportunity to propose some plan like this that's going to benefit you, but it also benefits EverSource, and they may be more willing to negotiate additional components. You see that the production here, or the consumption of the house, is 0.7. So this is like the smart building technology that I talk about. That's where essentially I create a smart server in the house. It's monitoring, the condition of all the lights, the conditions of the batteries, the condition of the weather, the conditions of the thermostats. Like it knows where everything's at. So now it knows that, EverSource is strapped. They're going to pay us if we contribute. So it makes sense for us to cut some loads and, lower our consumption during this time because, there's a financial reward on the other side of that. So whenever we get an event request from EverSource, the system knows to, hey, start looking at what loads can we cut. So we're not going to cut critical loads. So it's not going to be like the refrigerator or, stove or anything like that, but it's going to maybe cut the water machine. We have a water bubble here, or like the washing machines. Like you can wash clothes later. Like there's a financial reward keeping loads down right now. So like it makes sense to, you know, maybe wash those clothes later on and set it up also so like it pushes out notifications so everyone knows in the house or, you know, at the facility not to use specific loads. But it's more so of a reminder because they can just go use it. It's just not going to work because we control everything on the internal side. But we can play around with all that, and that just goes to show just kind of like how we can manipulate these systems to interoperate and kind of just get, you know, scaled efficiencies. And then the last part is the generator. So you guys already have a generator, which is amazing for, you know, just firing it up during peak demand. With the battery systems, those take over most of those peak load demands because you have that gas tank that's always there. So anytime there's a peak shock, the gas tank just pops in and just, you know, covers those loads. So you're not, you know, relying on Eversource at all. But additionally, you have that generator that can support in those moments of peak demand that we want. But the more role that I see the generator play, it changes from, like, let's say you guys currently have an outage. The outage could be, you know, 14, 15, 25 hours, 3 days. For you guys to power the building, you guys have to run that generator for 3 days, 24 hours, however long the outage is, which is, you know, additional fuel spend. That's going to be wasting quite a bit of money. Whereas if you had the battery systems, the generator only kicks on. Let's say, you know, it's rainy, and there's no sun coming out, whatever. So, you know, we have to run the generator. The generator kicks on and it only charges the battery systems. That's all it's worried about. So it doesn't have to run the entire time. It just charges enough to charge the battery system to 100%, and then the building just runs off the batteries. And then once it gets down again, we run the generator again. So it just makes things a hell of a lot more efficient. And having all these components in a microgrid facility, especially a healthcare facility, just unlocks, you know, tremendous benefits for the facility owners, you know, at $128,000 for like a system like this, but it lowers, you know, the area demand for Eversource. Eversource doesn't really have to worry so much about this area because it knows that at any point it could just request a VPP and it has energy coverage in this area. So that's just a different way to think about our energy use and ways that we could potentially make money off of it. And I'll be more than happy to continue, you know, the engineering on this and see if we can get it all installed. We can do it, you know, fairly quick. And I would advise moving quick if we're interested, just because, you know, laws are changing and tax incentives are changing, so it's going to change the economics of the plan that we put together here. But yeah, I just need basically a green light and start the engineering. It's a local like interconnection piece, and submit the proposal and see what happens.